All right, here's the first example of doing hypothesis testing with two samples. And in this case, we comparing two population means. Our samples are large. When I mean large, more than 30, 30 or more. The samples are independent, and we know the standard deviation of the populations. Okay, so when that happens, you just follow these steps, these 8 steps, and I'm going to show you with this example. It says here, a credit card watchdog group claims that there is a difference in the mean credit card debts of households in California and Illinois. The results of a random survey of 250 households from each state are shown at the left. The two samples are independent. Assume that sigma 1, standard deviation of the first population, is 1045 for California, and sigma 2, standard deviation of the population, second population, is $1,350 for Illinois. Do the results support the group's claim? Okay, use alpha or significance level or 0.05. So let's follow these steps, okay? And first thing, you need to verify, according to step number 1 here, you need to verify if you have sigma 1 and sigma 2, the standard deviation of the populations, of each population. And yes, I do. You can see it right here. Sigma 1, that's for California. Sigma 2, that's for Illinois. So I had that first requirement. Next step is, are the samples random? Well, when you read the word problem, it says here the results of a random survey. So yes, I met that requirement. The next thing I need to know is are the samples independent? And you can see around here the two samples are independent. So yes, it met that requirement. The next thing is, are either the population normally distributed? So when I read the word problem here, did I read somewhere here the keyword or the phrase normally distributed? No, I didn't see that, but I did notice that my my sample size are bigger than 30, and you can see that the sample size for each state is 250. So I met my first requirement. Let me put a check mark. Okay, let's go to the second step. Second step is state the claim mathematically. And how do we state the claim mathematically? In a previous chapter, I told you always underline the claim so you can translate literally the claim from words into math. And look what it says here. The watchdog group claims, here comes the claim, there is a difference in the mean. So I underline it in blue. And how do you write that? See, I'm doing now step number 2 because step number 1 already did it. Is there a difference between the mean? That means that the mean of California, let's call it mean 1, is not the same as the mean 2, that's for Illinois. Okay, that's how I translate that. Mu1 is not equal to mu2 because it says here there is a difference. In other words, they're not equal. Okay, and this is my claim. So I like to put in parentheses the word claim. Every claim has a counterclaim. So what is the opposite? Let's state the opposite of what it says here. Mu1 not equal to mu2. It will be mu1 equal to mu2. That's the counterclaim. Once you have the two claims, label the claims as HO and HA or H1. Whatever has the equal is going to be HO. So here it is. The first claim is HO. And the second one is H1. Look, I did step number 2. Step number 3, they asked me to identify the level of significance. In other words, how much is alpha? And when I read the problem, you can see here, alpha is 0.05. And I did step number 3. Step number 4, I'm going to do the bell-shaped curve. I'm going to draw it. Okay, so here's the bell-shaped curve. There it is. And I need to shade the tails, or one tail or two tails. Who always decide that? H1 or HA. That's the other name for H1. And because it's not equal, I'm shading both tails. Okay, let me choose a different colors to shade here. So there it is. I'm shading both tails. And that's step 3. Step 4 now. Here we go with step 4. We're going to find, I'm sorry, that was step, I think I'm counting this wrong. In fact, I already did step 4. That's step 4, the picture. Let me erase and let me label this correctly. Okay, so step 4 is, or was, the picture. Step 5, okay, is when we're going to find the test statistic. Okay, and what is the test statistic? It's a number describing something, okay, from the sample. And how do we find that? We find it using this formula here. So I'm going to use Z equal. Now here we go. We're going to plug in this formula right there. Who is my X bar 1? The mean of the first sample. That will be 4,777. Okay. And I need to subtract X bar 2. That's the mean of the second sample. 4866. And I'm going to put that in this parentheses. Minus. Now I'm going to subtract mu1 minus mu2. Okay. Now mu1 minus mu2, because if you look at the claim here, because these two means are equal, when I subtract them, this really is 0, because when the means are equal, this will be 0. That's why I'm going to put 0 here. Everything over the square root of. Now I'm going to fill in inside the square root. And I have first sigma 1 square. So the standard deviation of the first sample, I'm sorry, of the first population, I need to square it. So 1045 square. All right. And then I need to divide that by N1, the sample size of my first sample, which is from California. So that will be 250. And I plug in here. Plus, let's do now the second fraction here. The standard deviation of the second population, 1,350, and I need to square that. Everything over N2, the sample size of my second sample, that's from Illinois, is also 250. Okay, and again, I suggest when you're going to simplify this formula, use decimals. And that's what I'm going to do now. Let me go get the calculator. So here's my calculator. So I'm going to type all of this in here. So let me start with a fraction. Then I have a parentheses 4777 minus 4866. Close the parentheses, minus 0 over square root. And then I have one fraction, so I have 1045 square over 250 plus, and then I'm going to have another fraction, 1350 square over 250. And you can see my z-score. Now remember, z-scores are 2 decimal places, so it will be negative 0.82. This is my test statistic. Okay, z is negative 0.82. All right. Now remember that this number is going to be the label of my marks here. So this will be negative 0.82 for the first one. Why? Because in the middle is 0. Okay, so the negative numbers are on the left. And then on the right one, because I have a two-tail, it's the same number but opposite sign. So 0.82. And I did step 4. Now we're going, I'm sorry, step 5. I keep mixing up my steps. Now we're going to do step 6. We're going to find the p-value. And how do we find the p-value? We have to use the normal calculator, because since I'm working with z, I had to use the normal distribution calculator. So I'm gonna go and get it. All right, here's my normal distribution calculator, and remember I need to choose two tails. So click on the drop down menu. That will be the last I'm sorry, not the last option, the third option here. And then in the blue box, I'm going to type negative 0.82. And when I hit enter, I should get the same picture I have there. You can see I do. And here is my p-value in the red box. Usually you want 4 decimal places. So 3 decimal places. Let me go get that calculator again. Where did it go? Right here. 0.412. Okay. And that will be my p-value. All right, here we go, step number 7 now. So I did step 6. Now we're going to do step 7. I need to make a decision. And how do I make the decision? I'm going to compare my p-value against my alpha. Okay, and my p-value, that was step 6, I got 0.412. And my alpha is step number 3 is 0.05. And when you compare the p-value with alpha, you're going to see that the p-value is bigger. When the p-value is bigger, look what it says here. Our decision is going to be fail to reject HO. Okay, that's what you're going to do. Fail to reject HO. Okay, and I did step number 7. Finally, last step. Step number 8. I'm going to make the interpretation. Okay, and interpretation, we're going to use this chart. You need to know first your decision. We decided fail to reject, so I'm in the second row. And I need to know where's my claim. So that was step number 2. And you can see the claim is in H1 or HA, so I'm in this column. So find the intersection of the second row and last column, and it says here, there is not enough evidence to support the claim. So that's what I'm going to type here. Not enough to support the claim. And I did my hypothesis testing comparing two populations here about credit cards in California, credit card debt in California and Illinois. And these two samples were independent. Okay, the debt in California has nothing to do with the debt in Illinois. All right, I hope that helps.